Okay, this is the third video for the Unit 6 assignment. We'll keep on going here. Here we've got a carpenter building a wheelchair access ramp with a slope of 6/64. The height of the ramp will be 50 centimeters. What's the length of the ramp? In centimeters, rounded to a decimal place if the bottom of the ramp starts at 0, 0. I don't think that it matters where the bottom of the ramp starts, but maybe it will. Find out. So here's a little triangle showing a ramp. The ramp is 50 centimeters from here to here. And we want to know this side. This is our missing side, the run. How far over does it go? We know about this ramp that the slope is 6/64, which reduces to 3/32. And 3 is the rise, and 32 is the run. So once we know a rise, and we need to know a run, and we do know a set of rise and runs, we can just do a proportion to solve this. So 3/32, the slope that's given, is equal to 50 over something. We cross multiply 50 times 32 divided by 3, and we get 533 and a third, which is none of these. It's rarely the answer, actually, none of these, but there it is. Next, which of the following is equivalent to y equals negative 5x minus 2/3? All we need to do is rearrange them. These are all in general form or close to general form. Some of them have a negative x. And put y on one side and everything else on the other side. So for our first one, 15x plus 3y plus 2 is 0. We throw the 15 and the 2 to the other side. And then once we've thrown the 15 and the 2 over there, divide everything by 3. And that'll cancel out. 15 over 3 is 5. 2 over 3 is 2/3. And yes, that's the same. For b, we do something similar. We throw the y over to the right, divide both sides by 3, and we end up with negative 5x plus 2/3 is y. So no, that's not the same. For c, we throw the y over there to make it positive. That's all we need to do. It's just one y. So we get negative 5x minus 2/3. That's also the same. And for d, we get y is equal to negative 5x minus 2/3 if we just throw the 5 and the 2 over to the right. So 3 of these, A, C, or D, are equivalent. And you can also test all of these by graphing them. If they graph the same line, then you know it is the same line. Next, determine the slope of the line that's perpendicular to this line segment. We need to find the slope of this line. So this line goes up, well, 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. So 6/4 is 3/2. And so the perpendicular slope is, you flip it upside down and make it negative. So that should be A. I circled B. I don't know. I wasn't paying attention. That would be parallel. If the slope was 3/2, the same slope, that would be parallel, something like this. But we want perpendicular. We want a line that hits there at a right angle. Right angle. And that's a negative reciprocal slope. Next, predict what will be common about the graphs of these equations. Y equals 3x plus 6, y equals 3x minus 5, 3x minus 6, and 3x plus 5. So it's the same x term, just with positive negative 6 or positive negative 5 in there. This says none of the above. That's a scrambling questions issue. Just means none of the other choices, I hope. B says all the graphs will have the same x-intercept. If we graph them, we see it's not true. But also we can guess that it's not true because if we have all of these slopes that are 3, and we have minus 6 and plus 6 and minus 5 and plus 5, they're going to hit the x-axis at different spots. C, all the graphs will have the same slope. Yes, that's just given to us. Here's the slope, here's the slope, here's the slope, here's the slope. It's 3, 3, 3, 3 every time. D says all the graphs will have the same y-intercept. Nope, positive 6, negative 5, or positive 5. Next, what's the equation of this line? We want to know the slope and the intercept. We can put it into slope-intercept form. So the slope, we'll pick 2 points that go on nice intersections. We could have picked here and here. We could have picked those two, or that one and that one. Doesn't matter. Any 2 points that look nice to count from. And we start at 1, go to the other. We'll go over 1, 2, up 1, 2, 3. So the rise is 3, the run is 2. So the slope is 3 over 2. The y-intercept is right there at 1. So the y-intercept is b. The slope is m. Y equals mx plus b is y equals 3/2 x plus 2. I don't know why I said 2. Plus 1. Next, the point of intersection of this line on the y-axis. So we're looking for where it crosses the y-axis. Y-intercepts are where x is 0. So we're just going to make x to be 0. We can do this two ways. One of the ways is to make x 0 and solve for y. The other way is to graph it. So if set x to 0, 3 times 0 is negative 2y, or 3 times 0 minus 2y plus 1 equals 0. That 0 term goes away. And we get negative 2y plus 1 is 0. Throw the negative 2y over there, so it's a positive 2y. And then, now that we have 1 equals 2y, we need to divide both sides by 2. Cancel, cancel to get that y alone. And y is a half. So 1/2 or 0.5 or however it'll be typed into here. I think 0.5 is probably the easiest thing to type in. The other way would be to graph it and to just look at where the y-intercept was. It's also at 0.5 if we graph it. Wonder if I have that up. No, I graphed a bunch of stuff in preparation, but I guess not this. Okay, I'm going to stop this video and then we'll have one more to finish it off.